Hey guys, in this set of videos we're going to further explore the topic of angles. And so we've seen angles previously as these things that lie inside of triangles, but as we hop outside of triangles we're going to look at angles more broadly, so it's good for us to formally define what these things are. So just to begin with, an angle, it's an amount of rotation formed when two rays share a common endpoint. So if you remember from geometry, rays are these things that start in an endpoint and go on forever and ever in one direction. But you can see that any two rays that I stick together at a common endpoint that we call the vertex form what we call a rotation angle. So I'll have you take a look at my rotation angle that we've got here. And with respect to some of the anatomy of an angle, you'll notice first of all that this angle has a side that it starts at and a side that it rotates to. And it's always indicated by this inner arrow here, but the direction matters. And what we're going to see is that the side that our angle initiates at is what we call our initial side, or where it starts. And the side where it ends or terminates at is what we're going to refer to as our terminal side. So every angle is two rays shared by, or that share a common endpoint, and there's an initial side and a terminal side. One way of specifically drawing our angles or sketching our angles is going to be in what we call standard position here. Okay, so when we talk about an angle in standard position, let's go ahead and take a look at how this angle looks a little bit different than this angle I've got written over here. You'll notice that the initial side starts on the positive x-axis, and so we're going to make a note here. We say that if it's in standard position, the initial side is always on the positive x-axis. Okay. Another fact is that our vertex is at the origin, so the vertex is at 0, 0. By doing this, then, we can see that our angles really are just rotations either counterclockwise or clockwise from this initial side that is on the positive x-axis here. And so this illustration in particular shows an angle that rotates counterclockwise and terminates over here. And as a matter of fact, we should have an arrow on this, but you can see that our angle is formed in this particular case just by rotating counterclockwise from the positive x-axis. And that if we're going to speculate here, it has to be bigger than 90 degrees. So as we look at these angles in standard position, it's going to be important to note that direction of rotation matters here. So one of our first stops, or first things we need to talk about, is this idea that positive angles will always rotate counterclockwise from the positive x-axis, and negative angles will always rotate clockwise. And that's just kind of a common convention here. But it also just means that direction is going to matter in terms of signs. So make sure that you write down that positive angles go counterclockwise, negative angles go clockwise from the origin. And then our next stop is going to be to talk about four very special angles that we refer to as the quadrantal angles. And these are these angles: 0 degrees, 90 degrees, 180 degrees, and 270 degrees. And you'll notice that we also write 360 degrees over here. And that 0 and 360 degrees, although they're not the same, the angle, they do terminate in the same spot right there. So we can kind of classify this direction of east as being either 0 or 360 degrees. But these angles are just going to kind of help us navigate the plane as we rotate about. Okay, so let's take a look at maybe sketching some angles in standard position. Notice that we got kind of a variety here, but we'll just go ahead and start with a nice positive angle, 390 degrees. Now, one thing I know about 390 degrees is actually greater than 360 degrees, and given the fact that this is 0 here, counterclockwise we'd have 90, 180, 270, and 360. Okay, one thing that makes it really easy to do is to use these quadrantal angles to kind of talk about where we might lie. So first things first, because this is positive, we'll rotate counterclockwise from the positive x-axis, and we'll go at least 360 degrees around, or one full rotation. We could take our 390, subtract off the 360, and that would give us the fact that we'd have to rotate at least another 30 degrees. So looking at this is kind of like, it would be kind of stopping in the same place as a 30-degree angle. It would maybe look like this, and the way we tend to sketch this around is one full rotation and then another 30 degrees right here. And you can either label this at the end of the ray, or you can label this on the interior portion of the angle. But this is how we would sketch a positive 390-degree angle. And to top this off, what we also want to do is determine what quadrant it terminates in. So just to review our quadrants here, our quadrants are 1, 2, 3, and 4. You often see these written with Roman numerals, and they do run around in counterclockwise fashion from the top right, which is our quadrant 1. So in this case, this terminates in quadrant 1. I'll just go ahead and put a box around this here. How about letter B here? Well, a negative angle. And looking at this as negative angles, we still start at 0 degrees being here as our initial side's position, but this time we're rotating in a clockwise fashion. So this is actually negative 90, negative 180, negative 270, and negative 360. But in this case here, negative 160, it'd almost be like 20 degrees shy of negative 180. So we can almost imagine to make a 20-degree angle with the x-axis over here, look about this way. And we'll go ahead and draw on our arrow that indicates our direction of rotation here. And we'll go ahead and label on maybe this arrow down here, we're going to say negative 160 degrees in this case. And also we want to indicate that this terminates in quadrant 3, so quadrant 3 here. And then last but not least, 690 degrees. This one you might think is a little bit tougher, but it just means that we have more than one full rotation. So get in the habit of grabbing your calculator, and what we can do is we can also always just take our angle and subtract off increments of 360, one full rotation. Where might that lie? And then we'll tack on another full rotation. So if this is supposed to be stopping in the same place as 330 degrees, we'd say, well, here's 270, and here's 360. One full time around would be 360. 330 would be like 30 degrees shy of there. And so we would have our 330 degree angle plus another 360 degrees here. This would be our positive 690 degree angle. Okay, 690 degrees. So, and we also want to identify that this terminates in the fourth quadrant. So being able to sketch angles in standard position is going to be an essential skill here. And it's really helpful to use your quadrantal angles to help you kind of navigate, as well as adding on or subtracting off increments of 360. Cheers.